Hello, my name is George Bell. I'm the Personnel Manager of Daw Mill Colliery. I would like to take this opportunity of welcoming you to Daw Mill on behalf of the National Coal Board. Daw Mill is one of 13 collieries in the National Coal Board's South Midlands area and is regarded by many as the jewel in the crown of the South Midlands. The aim of this video is to give you an insight into what you may expect to see on your visit to Daw Mill. We do not wish to give visitors to Daw Mill a false impression of the nation's mining industry, as few coal board establishments can compete with Daw Mill in terms of profitability or productivity. However, Daw Mill is a shining example of the results that can be achieved by the British mining industry when sound investment is coupled with a spirit of mutual trust and cooperation. I sincerely hope you enjoy your visit.
Daw Mill was never planned as a new mine, but evolved as a natural extension to older collieries in the northern end of the Warwickshire coalfield. Kingsbury Mine produced coal in the early 1900s, and when the workings had extended some 2.5 miles from the shafts, it was clear that another shaft was necessary. In 1927, Dexter Shaft was sunk and was connected underground to Kingsbury for ventilation purposes. By 1955, the underground workings had extended some 7 miles from Kingsbury, and ventilation problems were acute. It was decided, therefore, to sink a new shaft 3 miles to the south of Dexter at Daw Mill. The shaft sinking started in 1957 and was completed in 1959. The connection to the Dexter workings was effected in the summer of 1960. It was in 1958 that a decision was taken to make Daw Mill a new colliery, a time when the National Coal Board was engaged in reducing output and closing pits in various parts of the country. To improve safety and maximize production, a second shaft was started in 1968 and completed by December 1969. By the late 70s, the colliery was consistently producing coal close to the shaft capacity. The National Coal Board, therefore, embarked on an extension to capacity scheme in May 1978, which comprised of a surface drift and new coal preparation facilities. The surface drift was commissioned in June 1983, and from that time, all coal produced at Daw Mill has come to the surface via its main trunk conveyors. Your guide will escort you to the pithead baths, where you'll be issued with locker keys. Please take care of these when underground. It does cause problems if they're lost. When changing, please ensure that all contraband, for example, matches, lighters, cigarettes, pipes, battery-operated watches, cameras, etc., is left in your locker. Owing to the possible presence of flammable gases and materials, we do not allow these items underground. After changing, you'll be taken to the lamp room, where you'll be issued with a belt, lamp, and self-rescuer. The self-rescuer is a device which enables the wearer to escape from an atmosphere contaminated with carbon monoxide, a product of fire or explosion. Your guides will demonstrate how to wear the rescuer. However, in the unlikely event of your having to use it, do not panic. Do not run. Do not try to talk. Just follow the example set by your guides. Remember, on no account must you remove the rescuer until told to do so by your guide or other responsible official. You will also be given 2 checks or tallies, 1 brass and 1 aluminium, each stamped with the same number. This is part of a system which we use to enable us to know who is underground at any time. After leaving the lamp house, you'll be taken to the shaft top by a route avoiding contact with moving vehicles, one of the many routine safety precautions adopted by the NCB. In normal circumstances, you will be descending the upcast shaft which serves to exhaust the air from the mine by means of a spur shaft or fan drift. By totally enclosing the top of the shaft, we prevent air short-circuiting, thus drawing air into the mine via the downcast shaft. To gain access to the top of the shaft, you'll be taken through a series of air doors. As you proceed through the doors, the pressure difference may give rise to a popping sensation in the ears. However, a quick swallow will remedy the situation. When the banksman gives permission for you to enter the cage, he may make a search for contraband, as previously mentioned. Give him your aluminium tally, which he will transmit to the deployment center. We will then know that you are underground. There is no need to regard your 1,800-foot descent with any apprehension. You have our firm assurance that the ride is as smooth as any lift in a large department store. Well, almost. After leaving the cage, your guide will once again check your lamps before you proceed. As the environment underground is no doubt a new experience, it's wise to be on the side of caution. Please follow your guides. They will take the safe way. Beware of moving ropes and locomotives. Walk on the outside of curves. Pay heed to strange sounds, klaxons, bells, sirens, etc., which may signify the starting up of machinery. Traveling to and from the coalface can take a considerable amount of time. As this time is non-productive, efforts have been made to minimize its effect by providing man-riding facilities. The main man-riding systems at Daw Mill are endless rope trains. 20's man-rider will take you to the southern districts, and 1's man-rider will take you to the west. Please keep well within the confines of the carriage. Board and alight only when told to do so by your guide. The man-riding trains are also used for the transportation of supplies to the production districts, and although efforts will be made to acquire them for your use, supplies take priority. If you are visiting the southern section of the mine, you will be riding on a conveyor belt approved for man riding. It is customary for this belt to be stationary when visitors get on and off, but in normal circumstances, this would be done whilst the belt is in motion. Visitors are advised to lie flat on the belt with arms and legs kept well away from the edge of the conveyor. Please allow 5 yards from the person in front. The words district and face will be used regularly throughout the course of your visit, so it's well worth giving you a brief explanation of their meaning. A district is any section of the mine defined by the manager, for which he wants someone to be directly responsible. It may be a production or development district. A face, or coal face, is best described if one thinks of a rectangular block. 2 parallel sides of the rectangle are the roadways to and from the face. One of these, called the main gate, brings fresh air to the faces, and the other, called the return gate, takes the stale air away. These roadways are part of an overall ventilation system, which starts at the intake shaft and finishes at the upcast shaft, and is crucial to the safe working of a mine. Short-circuiting of the system is prevented by an elaborate series of air doors. When you reach the face, you'll notice that there are men working on the roadway pack. When the face advances, a cavity is left behind the supports, most of which is filled by a natural cave-in of the strata. The cavity area closest to the roadways is filled with a mixture of coal fines and cement. This is known as the pack. Its purpose is to provide an airtight seal between the cave-in area and the roadway, as a precaution against spontaneous combustion, and also to cushion the roadways against the effects of strata movement. The faces at Daw Mill are, on average, 3.5 meters high and 230 meters long. You'll be reassured by the fact that there'll be no kneeling or crawling on your underground visit. Daw Mill faces are equipped with 2 cutting machines, which may be likened to mobile bacon slicers. Each time these machines traverse the coal face, they cut and load some 600 tonnes of coal. At the face ends, the machines also cut out the roadway profile, thus eliminating the need for shot firing and hand filling. The face is supported by some 145 hydraulically operated chocks or supports, which are equipped with forward sprags to prevent the coal breaking from the face. The face cycle is as follows. For simplicity, the diagram shows only one machine. The machines proceed along the face, cutting the coal and loading it onto the face conveyor. They are followed by the snakers and chockers, responsible for snaking or pushing over the conveyor and moving the supports forward. The supports are coupled to the conveyor by means of double-acting rams, which, when activated, advance the conveyor to its new position ready for the next traverse. Next, the supports are lowered slightly from the roof and pulled to their new position, using the same ram which pushed the conveyor over. The supports are then reset tight to the roof. The unsupported strata above is allowed to fall into the waste behind. To sum up, the support is used as an anchor to push the conveyor forward, and the conveyor is used as an anchor to pull the supports forward. As the face advances, the roadways to it need to be extended. The 16 by 12-foot steel arches are erected by the front rip teams after the coal face machines have extracted sufficient coal from the face side. The area between each arch setting is covered by corrugated steel sheets, and each arch is fastened to the others on either side by struts. At the coal gate end of the face is the stage loader, which loads coal from the face onto the first of a series of conveyor belts, which takes the coal to the surface. All ancillary equipment located in the roadways is systematically advanced as the faces themselves advance. At the time of making this video, 1,308 men were employed at Daw Mill on the industrial side. The number of men employed underground during a shift can be anything up to 500. Most people working underground are employed on backup work, maintaining roadways and taking in supplies. Pressures inside the earth are continually exerted against our roadways, resulting in either buckled supports or floor lift. Both reduce the roadway height, thus making transportation of supplies very difficult, as well as restricting ventilation flow. Roadways are repaired by either dinting or ripping. Dinting is where the floor strata is extracted, usually by machine, and ripping is where the buckled arch is taken out, encroaching strata removed, and new supports set. As the faces and roadways advance, more materials are required to construct the roadways. Supply men move these materials to the point of advance via rope haulage systems, either track or monorail. Each supply route has an emergency stop cable as an essential safety device. The vast network of conveyor belts also needs to be cleaned, maintained and extended in order that the flow of coal from the coal face to the surface is as continuous as possible. The coal seen in this video takes approximately 45 minutes to travel to the surface, where it's prepared into a saleable product. We trust you will find your journey up the shaft just as smooth as going down. When you leave the cage at the top of the shaft, give your brass tally to the banksman. When both tallies are returned, we know that you are safely on the surface, and we sincerely hope you've enjoyed your underground visit.
We have only attempted to give a very brief outline of the workings of a coal mine. No doubt many of you will have more specific questions which you will want to ask. Please feel free to ask as many questions as you wish and direct them either towards your guide or the men that you see on your visit.